I definitely played in the dirt when I was a kid, and still do today. The most pleasant thing about this field is that you're not stuck behind a desk.
Every day's a challenge.
Every job that I have is different.
You don't spend your whole day in the office looking at a computer screen.
You get to go out and see the construction as it happens.
The ever-increasing demands of modern civilization and burgeoning population centers around the world have intensified the need to build longer and bigger bridges, taller skyscrapers, and stronger levees. But often, the ground we choose to live on is not as stable as we think, or as safe as we would like. Without solid ground to build on, all of this can be wiped out in just a few seconds. Today, every construction project must begin with a study to determine how the ground will behave when a structure is built on a specific site. The specialized mission of geotechnical engineering is to study precisely how the ground behaves.
Most people on Earth don't know what geotechnical engineers do.
It's essentially dirt with numbers.
The job of every geotechnical engineer is to identify both existing and potential hazards, and to provide efficient and cost-effective solutions to ensure that the visions of architects, contractors, civil engineers, and designers can coexist with the realities of the earth and of nature.
Geotechnical engineers deal with things below the ground. That's what our job is about. It requires a lot of problem-solving skills. There are always some kind of problems involved with developing a piece of land, whether it's for a big structure or a lot of houses, and the answers aren't always obvious because you're not just cranking answers out on a computer. You have to draw on your experience and experience of others to find the solutions to the problems and then try and keep them economical, because part of engineering is coming up with economical solutions to problems rather than just spending your client's money like there was no end to it. So we do geologic and geotechnical investigations of these hazards and then develop ways to mitigate them.
After ravaging large parts of New Orleans and surrounding areas, Hurricane Katrina posed a number of unique geological and geotechnical challenges to engineers charged not with simply repairing existing damage, but with determining how to make improvements to prevent similar catastrophes in the future.
The morning after Katrina, when the rains had kind of slowed down, people were starting to wonder why the water was still coming up in their neighborhoods. That was partly due to all the levees along the canals here in town that they used to evacuate rainwater from the city out into Lake Pontchartrain had breached. So one of the things they're looking at is increasing the heights of the levee. Well, unfortunately, the soils here are not strong enough to support any additional load. So that's one potential use of the dry soil mixing method. Can be used underneath these levees to allow them to build them, a couple of 2-3 feet higher. It's a new method. It's only been employed in the United States a few times, since it's not so widely known here in the United States. So, you have to really use innovative ideas to solve their problems.
You have to have good reasoning skills and good common sense to avoid being overly conservative when you're designing a project, yet you have to keep the public's safety foremost in your mind. So you don't want to allow the client or the builder to build a project that isn't going to be safe for the public, because that's our ultimate client.
We're just trying to protect the people that are going to be occupying the buildings that we're helping to design. So basically we're just trying to save lives.
Maintaining public safety in a major earthquake zone such as the densely populated San Francisco Bay Area confronts geotechnical engineers with numerous complex and demanding problems requiring new and innovative solutions. Geologists know that it's not a question of if another major earthquake will strike the metropolitan Bay Area, but when. One of San Francisco area's greatest assets is the Bay Area Rapid Transit System, also known as BART. The crown jewel of the BART system is the Transbay Tube, which was built over 30 years ago. This year, BART initiated a variety of studies to evaluate the potential vulnerabilities in the gravel backfill around the Transbay Tube. They hired a team of highly experienced geotechnical engineers who decided to use the vibra replacement technique to build columns to densify the fill to prevent liquefaction during an earthquake. The engineers have to rely on the most advanced technology to position the probe in the required location. This project presents a new level of difficulty in conducting the work. There are no benchmarks floating in the bay, nor are there markers delineating where the tube is. The probe has to go blindly through up to 90 feet of open water before it reaches the soil on the bottom. All this while the trains are running through the tube with all the risk involved in case of an error.
My work can save lives by thoroughly investigating a site and determining the type of materials that are out there, and if an earthquake were to occur, help mitigate the potential for seismic loads on buildings.
The sense of pride lies in knowing that you did a good job in putting up a structure that is going to be sound even under earthquake conditions or other adverse conditions that might otherwise impact the structure, and that it's going to stay standing.
It seems as though we really do need more geotechnical engineers.
It is a very interesting and gratifying career.
You get to deal with the contractors. You get to deal with clients. You still deal with all aspects of civil engineering, but you get to get out into the field.
It's a branch of civil engineering that should be looked at and should be taken more into consideration.
There is a nationwide shortage of engineers of all type, and in geotechnical engineering it's worse.
Weekly or monthly, we're getting phone calls from professional recruiters, from other companies, just trying to get you to go to their company and look for the greener pasture. As soon as you graduate, of course you don't have a lot of experience yet, but still, companies realize that they need to get younger people into their profession, and so that you're still getting hired even though you don't have all that experience behind you yet. So they're willing to take their leap of faith that you're going to be a valuable employee just based on the 4 or 5 or 6 years of college preparation that you've done.
We go to great lengths to try and find qualified candidates, and there are so few available right now that it would be a good career to pursue if you're interested in getting a job right out of school and continuing through.
Do you want a challenging and fun career? Have we convinced you that geotechnical engineering is the career for you? Well, come join us. For more information, speak to your local CGEA representative to find out what you can do to become a valuable member of the geotechnical engineering community.